Welcome students to yet another session on transition metals. In this session, I'll be dealing with two important compounds of transition metals, namely potassium dichromate and potassium permanganate. The study of these two compounds is important because of their property of acting as very good oxidizing agents. In fact, these two compounds are not unknown to you. You are using this orange colored potassium dichromate in your chromyl chloride test. Chromyl chloride test in detecting the chloride ion in your salt analysis. And you are using the potassium permanganate solution as oxidant in your redox titrations. Isn't it? You are also familiar with the use of these two compounds in organic reactions as oxidizing agents. To give an example, the primary alcoholic group can be directly oxidized to carboxylic acid by the use of either the dichromate ion or permanganate ion solution. Now coming to the study of potassium dichromate, let us see first how it can be prepared. It is prepared by treating chromate ore. Formula is FeCr2O4. Chromate ore is fused with sodium carbonate in the presence of air. You know what is fusing? Fusing is heating the two solids to high temperature. The chromate ore is fused with sodium carbonate in the presence of air. When you get sodium chromate, Na2CrO4 plus Fe2O3 plus CO2. The balanced equation goes like this: 4 FeCr2O4 plus 8 Na2CO3 plus 7 O2 giving 2 Na2CrO4, 8 Na2CrO4, 2 Fe2O3 plus 8 CO2. 8, this is 8 Na2CrO4. Right, now when you extract the product with the water, the solution is in yellow in color due to the presence of sodium chromate. And you get rid of the Fe2O3 by filtration. And you take this yellow colored solution and treat it with acid. This is the second step. You treat it with acid when the chromate is converted to dichromate. Two Na2CrO4 plus 2H plus giving Na2Cr2O7 plus 2 Na plus, that is left out here. You get 2 Na plus H2O. Okay. The third step is you are taking this orange solution, the sodium dichromate solution, Na2Cr2O7, and treat it with KCl solution. A double decomposition reaction takes place and it gives you potassium dichromate and NaCl. 2 KCl here and 2 NaCl here. Yes. So these are the three equations and reactions involved in the preparation of potassium dichromate. In the first step, we are fusing chromate ore with sodium carbonate in the presence of air, and you extract the product with water, which is yellow in color. You filter that to get rid of Fe2O3 and treat it with acid or acidify the solution, which leads to the formation of sodium dichromate, and the sodium dichromate is then treated with potassium chlorate solution to give you potassium dichromate. Potassium dichromate, being less soluble, crystallizes out first. It is filtered and dried. So this is for the method of preparation. In the above three reactions, second reaction is the treatment of sodium chromate to give um, with acid to give sodium dichromate. In fact, a chromate ion on treatment with acid gives dichromate ion. This is a general reaction. Chromate ion, which is yellow in color, gives orange color dichromate ion. To balance, let me write 2CrO4 2 plus 2 minus to give plus 2H plus giving Cr2O7 2 minus plus H2O. The dichromate ion in turn on treatment with a base or an alkali gives the chromate ion. Two OH minus giving 2CrO4 2 minus plus H2. So it is important to remember these two reactions of converting chromate to dichromate and dichromate to chromate. You can be given the question this way: what happens when you lower the pH of a chromate solution? Or what happens when you increase the pH of a dichromate solution? You know, lowering the pH means acidifying. You have to understand that it means the same thing as treating a chromate ion with acid. Similarly, increasing the pH of a dichromate solution means adding an alkali or a base, in which case the dichromate is converted to chromate ion. Let us see how we can write the structure of these two ions. A chromate ion can be written as it has a structure like this, and the dichromate ion has a structure like this. The chromium atoms are in the center of a tetrahedron. The two chromium atoms are in the center of tetrahedrons. Here also the chromium is tetrahedrally surrounded by the oxygen atoms. So this is about the structure of the two compounds. Now there is one more very interesting to know about the potassium dichromate is it is used as a primary standard in volumetric analysis. Primary standard. Let us try to know what is meant by a primary standard in volumetric analysis. Now you see, you prepare standard solution of potassium permanganate and use it in titration against ferrous ammonium sulfate or oxalic acid. Right. The potassium permanganate, when you prepare, you have to use it immediately. If you keep it say for a week and then come back to do the titration, you cannot substitute the value of its concentration and do the calculation because its concentration would have varied. Actually, if you look at the bottle, there may be some black sediment at the bottom, which is due to the presence of MnO2. So the concentration of potassium permanganate changes over a period of time. We say it is not a primary standard. So what is a primary standard? A primary standard is a solution whose concentration remains the same over a long period of time. But if you prepare a solution of potassium dichromate, this can also be used in volumetric work in redox titrations as oxidant. When you prepare a standard solution of potassium dichromate and note down, calculate its exact strength, and you continue to use the solution even after a month, you can be sure that the concentration remains the same and you can substitute the strength in your calculations and get the results. So that is the difference between what what you should know as primary standard. Potassium dichromate is a primary standard, while potassium permanganate is not a primary standard. This might be of use to you when you answer your questions in Viva during your practical examinations. The next thing is you have to write balanced equations for the redox reactions involving potassium dichromate. You know potassium dichromate is a good oxidizing agent. It oxidizes Fe2 plus to Fe3 plus, H2S to sulfur, then I minus to I2, NO2 minus, nitrate ion to nitrate ion, sulfite ion to sulfate ion, to name a few. You have learnt two methods of balancing the equations already. In this section, I will take up the ion-electron method or the half reaction method. The common half reaction in all these things is the reduction half, in which the dichromate is reduced. In all these reactions, the dichromate ion is reduced and it oxidizes ferrous to ferric, H2S to sulfur, etc. So for the reduction part, the reduction half reaction, which is common in all these reactions, is Cr2O7 2 minus is reduced to Cr3 plus. This you have to remember. The rest of the things I will teach you how to do on your own without having to memorize them. But this part, that dichromate ion on reduction gives Cr3 plus, you have to remember. You have 7 oxygen atoms on the left, which should be balanced by writing 7 water molecules. So you have got 7 oxygen here, but you have introduced 14 hydrogen here, which should be balanced by writing 14 H plus. Right? So the atoms are balanced. Chromium, oxygen and hydrogen atoms are balanced on both sides. You have to balance the charges now. No, I'm sorry, you have not balanced the chromium atoms. So let me put 2 Cr here. To balance the charges, on the left hand side you have 2 negative and 14 positive charges. That is a net of 12 positive charges you have on the left, and you have 6 positive charges on the right. So this is balanced by writing 6 electrons on the left hand side. So when you write 6 electrons, the charges are balanced. Also, addition of electrons is reduction. So that means the dichromate ion is reduced to Cr3 plus. We have to take the other things one by one. Let us first take Fe2 plus. So the oxidation half reaction for that will be Fe2 plus giving Fe3 plus an electron. Loss of electron is oxidation. So this is the reaction, equation for the oxidation half reaction. But the thing is, we have to balance the electrons also in these two reactions. Since you have 6 electrons involved in the reduction reaction, you have to have 6 reactions here also. So we will multiply this equation by 6. When you do that, here you get 6 Fe2 plus giving 6 Fe3 plus 6 electrons. Right. Now you have to combine these two equations and write the overall equation. So the overall equation would be Cr2O7 2 minus plus 14 H plus 6 Fe2 plus giving 2 Cr3 plus 7 H2O plus 6 Fe3 plus. Do you find it easy? So I taught you how to write the reduction half reaction and oxidation half reaction separately, balance the number of electrons and add to get the final equation. The basic thing you have to remember is, in the reduction half reaction, the potassium dichromate is reduced to Cr3 plus. If you remember that and you know how to balance the oxygens and hydrogens, you can easily write the equation. Next, we will take up the oxidation of H2S to sulfur. To balance the two hydrogen atoms here, we will write 2H plus on the right side. To balance the charges, the two positive charges here can be balanced by writing 2 electrons. Remember, the reduction half reaction involves 6 electrons. So, we have to balance this part of the reaction by 3 so that we get 2H2S, 3H2S giving 3 sulfur plus 6H plus 6 electrons. Combine it with the other half of the reaction, you will be getting Cr2O7 2 minus plus 14H plus 3H2S giving 2Cr3 plus 7H2O plus 3 sulfur plus 6H plus. Now H plus is on both sides, so we will cancel, right, 8H plus. So your overall reaction will be Cr2O7 2 minus plus 8H plus 3H2S giving 2Cr3 plus 7H2O plus 3 sulfur. I suppose you have learnt how to write these equations on your own without having to memorize them. If we take up the oxidation of I minus to I2, the oxidation half reaction will be 2I minus giving I2, and to balance the two negative charges on the left, we will write 2 electrons here. Okay. Again, you know you have to multiply this by 3 to get 6 electrons so that the electrons cancel out. You get 6I minus giving 3I2 plus 6 electrons. And combine it with the other half of the reaction, you get Cr2O7 2 minus plus 14H plus 6I minus giving 2Cr3 plus 7H2O plus 3I2. So it is enough. We will take up one more oxidation by the dichromate ion, NO2 minus getting oxidized to NO3 minus. How will you balance the oxygens? You have 2 here, you have 3 on the right side. So you have learned that to balance the oxygen, you have to write water. Now you have introduced 2 hydrogens here. You balance that by writing 2H plus on the right side. After balancing the atoms, count the charges. You have 1 negative charge here. You have 1 negative and 2 positive. That is a net positive charge. Obviously, we need 2 electrons on this side to balance the charges. In this equation again, you get 2 electrons. So you must be knowing what to do now. You will multiply this by 3. You get 3 NO2 minus plus 3 H2O giving 3 NO3 minus plus 6H plus 6 electrons. Combine it with the reduction half reaction, which is Cr2O7 2 minus plus 14H plus. Adding this, you will get 3 NO2 minus plus 3 H2O giving 2Cr3 plus 7H2O from the other equation plus 3NO3 minus plus 6H plus. Two things lie on both sides. H plus, you have 14 here, you have 6 here. So that will give you a net 8H plus on this side. And then you have 7H2O on the right side and 3H2O on the left side. That will leave you with 4H2O on the right side. So this will be your balanced equation for the oxidation of the nitrate ion by dichromate ion. So I suppose you found this session useful to learn how to write balanced equations for the redox reactions involving potassium dichromate. I will take up the preparation and reactions of potassium permanganate in the next session.